So this is a partial. So now this is an improper fraction. This partial is improper fraction because the power here, this is power 4. And when we expand this, we are going to have power 3. So we will need to divide this so that we'll get the quotient. So first, let's expand the denominator. Let's expand the denominator. So for dividing for this one, we can't use the other method, but we use the long division. So what we have is, let's expand that. So we are saying this will be x to the power 3 plus 2x. That's how the denominator will be. So we will divide like that. So now take note how we divide when we have such kind. Please take note. Girls, take note. The girls take note. So we have x to the power 3. So when you have that, you put it like that. You have x to the power 3 plus 2x like that. Then what you get is the denominator, you have x, or under, you have x to the power 4 minus x to the power 3. Then you have minus 2x. So you have to put also 0, since here and here, to the power 3. The next that should follow is to the power 2. So since we don't have to the power 2, it will be 0, x power 2. And that's when we have minus 2x, then minus 1, a constant, like that. So what we do is we'll say this into that. So we are saying x to the power 4, this x to the power 4, divide x to the power 3. That's how you do long division. This divide that, we will say the 3x will go, and that this will give us x. So we'll have x there. Then when you have x, you multiply this same x times x to the power 3. X times x to the power 3, what do you get? X to the power 4. Then x times 2x, that will give us 2x squared. So you can't put it where there is x cubed, you put it where there is x squared. So it is 2x squared when you multiply. So we are multiplying. After dividing, you first divide x to the power 4, divide x to the power 3 to get x, is what you write on top. Then you say x times x to the power 3, we get x to the power 4. Then here, it means here what we have is 0, x cubed, like that. Then what we can do is we subtract. When you subtract, of course, x to the power 4 minus x to the power 4, that gives 0. Then we have minus x to the power 3 minus 0, so it will just be minus x to the power 3, like that. Then we have 0 minus 2x to the power 3, 0 minus positive 2, so it will be negative 2x power 3. Then we can bring down this minus 2x, like that, and minus 1 possibly. Just let's bring them together, because that will be
Isn't
the
it 2x
last.
to the power 2?
2x to the power 2, good girl. You are following. Just wanted to see if you are following. 2x to the power 2. Then after you do that, you are going to get the first in front, x minus x to the power 3, divide x to the power 3. Divide x to the power 3. This will just give you negative 1, because x cubed, they cancel, and you only have negative 1 that will remain. So there you are going to have minus 1. Then minus 1 will multiply. So minus 1 times that will give us minus x cubed. Then minus 1 times that. Okay, so minus 1 times that, it will give us minus 2x. So we'll put it here, minus 2x. Then it means this, which we don't have my zeros. So this will be 0, x squared. And here we are going to have plus 0, like that, so that we can have the final stage there. So what we have is this minus that, that's a 0. This minus nothing, that will give us minus 2x squared. Then minus 2 minus 2, that will give us 0. So we are going to just remain with minus 1 minus 0, that will give us minus 1. So the remainder is minus 2, like that. So it means this has been expressed as, so this is the quotient. So it has been expressed as x minus 1 plus the remainder is this. So you put minus 2x squared minus 1 like that over the same denominator. It doesn't change. It's x open bracket x squared plus 2. Now this one which we have here is the one that will deal with a partial. So if you've seen, you've already found the value of A and you found the value of B, because here it's x minus 1. So if you are to compare here, A is 1, B is -1. So you are just yet to now find the expression for this. So now the partial to deal with is this one. So let's resolve that partial. Okay, up to that stage, I've talked too much. Any questions? Up to that stage, any questions?
No.
Okay, then let's now do the partial for this one. So we are saying this has been given us. So whatever that was given, it is x minus 1, then plus, here we have minus x squared minus what did we get? Minus 2x squared minus 1. Minus 2x squared. Don't let me go and then you'll make corrections. Minus 1 over, then we have x, open bracket x squared plus 2, isn't it? Plus 2. Then this, you have already, this they can't do anything, so resolve this partial. So it's to resolve now the partial, resolve the partial. So the partial that we are resolving is this guy. So you have minus 2x squared minus 1 over x squared plus 2 equals, this is a linear root, so it's a over x, plus this is a quadratic, so it will be bx plus c over x squared plus 2. So let's do this. So we cross multiply, or we multiply throughout by x and x squared plus 2. So when we multiply this by that, this and that cancels, we remain with minus 2x squared minus 1. Then this times that, so it means this will multiply that. So this will be a multiplying x squared plus 2. Then plus bx plus c will multiply x. Then we can expand this, so that will be minus 2x squared minus 1 is equals to, we can have ax squared plus 2a plus b x squared plus cx. Then we can come up with the equations. So we'll come up with the equations. So we'll start with the one that has x squared as coefficient. So coefficient of x squared, what's the coefficient of x squared on the left-hand side here? What's the coefficient? The number in front of x squared here is what? Negative 2. Then equals, here x squared, we have a, x squared, we have b, so a plus b. So we call it equation 1. Then we go to those that have a coefficient x. So this side we don't have x, so the coefficient x here, it's 0, and this is equals to, here the one that has just x, it's c. So c automatically is 0. Then we go to constants. Constants, those that do not have that, so we have -1 on the left hand side. Then here the constant is just minus 2a or 2a. Then this equation 2a is equals to -1 can help us find the value of a. We divide by 2, we divide by 2, which means a is equals to -half. And if we have a as -half, C as 0, we'll be able to find B. So B, we'll get this equation, A plus B is equals to -2. Substitute our A with -half plus B is equals to -2. So B is equals to -2 plus half. So B is equals to -2 plus half, that is -3/2. So these are the values of A, B, and so it means after resolving the partial, the value of A here, the value of A, we've resolved that partial, the value of A is, the value of A is -half. So we have -half here. So since they want it like that, we can put -half. The value of B is -3/2. -3/2 x, so -3/2 x, and C is 0, like that. So now we go back to the question. So you find that the values, we found the values of A. So here, expressing it like this, A, we found this x minus 1. So we found it, this is x minus 1. So it means our A from these two, A is 1, the number in front of x, B is -1, C, the number on top of x here, it's negative what? -half. So this one is -half. So we are saying this is -half where there is C. So it's -half over x, then plus D is -3/2. -3/2 of x squared plus 2. So we have found the values of A, B, C, and G. So we are saying C is -half, D is -3/2. Please take note, these values we have put, they are not coming from the resolved partial. The resolved partial we already solved here. We were just resolving the partial for this second part here. So now when we substitute direct here, we have this expression here, which is this. And this is the one that we take there. So this is the -3/2. This is the -3/2 x that we have there. So this is the one that we lift and take it on the other hand here. So now it means the expression that we are looking for is this. Any questions up to that stage? The one that asked, are you happy?
I'm very much happy.
So the next thing that we do now, they want us to integrate it. So it means we have this. We have this. So we are saying, now we are saying integration from 1 to 2. The limit is 1 and 2 of x minus 1. Then this one is minus, we can now have it -1 over 2x. Carry -half, we can just put the 2 in the denominator, change there. Then we can have minus.
Sorry, Mister. It's supposed to be, what the 2 is there on the integration, it's supposed to be 3. It's 1 and 3.
Oh, 1 to 3, like that.
Yes.
Yes. Then -3 over 2x over x squared plus 2. So we are integrating this. So now, What's the integration of x? Integration of x by x squared over 2 e. Integration of a constant minus 1, it will just be minus x. Integration of this one, it will just be minus the way it is. 1 over 2 is a constant, the natural log of x. Then integration of this is the one that we are going to use substitution method. So this part you are going to use substitution method. So you already have 3 over 2 as a constant. Then use substitution method in integrating this x over x squared plus 2. So integrating this, we are going to say let u be equal to x squared plus 2. Then we are going to have du dx as equals to 2x. Then make dx subject, so we cross multiply. So it will be du over 2x is equals to dx. Then we are going to, so we have it like that as we are integrating that. So we are going to have x over, we are saying this will be u. Then we are going to replace du with over 2x. Then the x and that cancels, so the 2 is a constant. So we are going to have a constant. So 2 has a constant, then 1 over 2, the natural log of u. And our u in this case is x squared plus 2, like that. So this is what we have. So now with this, with the limits from 1 to 3. So this is what you get. Then you can substitute in 3 and solve. When you substitute in 3, solve the answer, minus substitute in 1, solve the answer. Is it clear? Or I've done it too quickly?
How is this one?
Yes, you are too fast.
Yes, so repeat. Maybe on a first
On a separate,
Let's go.
on a separate paper?
Yes.
Okay. You won't like me when I do it slow.
Why not?
Okay, give me. Those of you who are coming who are coming to Lusaka after you write your exams, you should even come and take me out by East Park.
Don't worry, we'll come check you out.
Okay. Me, I'll be on you. Hello, man. I would have commented if I was not recording. Let me pause. So you are going to integrate term by term. So we'll start with this one. Integration of x. When you integrate x, what do you get? It's x power 2 over 2. Because this has the power 1, so you are going to add plus 1 to the power so that it's 2 and you divide by 2. Then you come to this one. Integration of a constant, it's just gains x. So it will be minus x. Then this one is in form of 1 over n. So this one will be minus, this 2, you bring it out, so it will be minus 1 over 2, the natural log of x. Like that. Are we together? Then you come here. So now, to integrate this, I said you are going to integrate this. Let's integrate this, Aaron. We know it will be minus here. Let's integrate 3 over 2x over x squared plus 2 dx. We are integrating this guy, Aaron. You are making noise. Okay, so say let u be equal to the denominator, which is x squared plus 2. So we are integrating by substitution method because we have a here hex and you have hex there. So let's have du dx differentiation. When you differentiate to x to the power 2, what do you get? You get 2x, isn't it? Differentiation of a constant gives you what? 0, isn't it? Okay. Then let's cross multiply here. So we are going to have du is equals to 2x dx. Then dx should be made subject. So you divide by 2x, even this side 2x. So that dx remains around, and you are going to say where there is x, will replace with du over 2x. Then we'll come back to this one. So integration of that guy, it's still 3 over 2 hex. Where there is the x here, you replace with what we have found as du over 2x. Then x squared plus 2, we have replaced x squared plus 2 with u, like that. Then what you have is this x and that x cancels. Then you are going to bring out this 2 and this 3 over 2. So this 3 over 2 is brought out like that as 3 over 2. This 2 is brought out, it will multiply that 2. Then what you remain with in the numerator, it's just 1 over u du. And I said this 3 over 2 times